Hi everyone, so we are given with a question which says the galvanometer deflection when the key K1 is closed but K2 is open equals to theta naught, as we can see in the figure. On closing K2 and adjusting the value of R2 to 5 ohm, the deflection of the galvanometer becomes theta naught by 5. The resistance of the galvanometer is then given by, we can neglect the internal resistance of the battery. So here we have to find the value of resistance of galvanometer G. So we can divide whole of the question into two parts. So first is when K1 is closed. Let's write it clearly. And K2 is open. So when K1 is closed and K2 is open, the current will flow only through the galvanometer. And let's suppose that current to be as I1. So I1 can be written as uh, V, that is by Ohm's law we can write it as E upon total resistance, that is 220 plus of G. Alright, so let's suppose that this is our equation 1, and also we have been given that this current is the galvanometer deflection is theta naught. So we can write here as theta naught. Why I am writing directly theta naught as I1? Because we know for galvanometer the current is directly proportional to the angle of deflection. Alright, so uh, now let's move on to the second part. In the second part it says switch K2 is closed. Now both the keys are closed, so we can write K1 K2 both are closed, and if both are closed we can say the current that is flowing through the circuit can be given as total. I am writing it as I only, that is total current in the circuit can be again calculated by using Ohm's law, that is E upon total resistance. Total resistance we can see R1 is in series with R2 and RG, means G, as R2 and G both are in parallel and they are in series with R1. So we can write the equivalent resistance that can be written as 220 plus of the parallel combination of R2 and G, that can be written as R2 by R2G into R2 into G divided by R2 plus of G. Alright, and we have been given the value of R2 as to be 5 ohm. We will substitute the value of R2 as 5, so we can write it as E over 220 plus of 5G, and that's divided by 5 plus G. On cross multiplying the term, we will get the value of total current in the circuit as E into G plus 5, and that's divided by, we can write it as 1100 plus of 220 G plus 5G, that comes out to be 225 G. I'm directly writing 225 G. Alright, now we have been now uh, in the second part we have been told that the deflection of galvanometer is theta naught by phi. So galvanometer shows deflection when the current passes through it. So if the current, we have supposed that the I current is flowing through the circuit and this I gets distributed, let's suppose that into I1, and let's suppose it has to be uh, to avoid the confusion we have already used the I1 over here, so we will write it as the current will get distributed into let's say I dash, I1 dash, and let's say I2. Alright, so when for I2 value of current, when I2 current is passing through G, so galvanometer will show theta naught by 5 deflection. So we need to first calculate the value of I2. So for that we will write also it's been given I2 is equals to theta naught by phi. Alright, so this deflection comes into picture when the current passes through the galvanometer, as same is the first case when I1 current was passing through the galvanometer, because no current were passing through this resistance or in this elements. So we have written theta as theta naught as I1. Alright, so now we are interested in finding the value of I2. For I2 I would suggest to remember this trick. So we are interested in finding the current through this resistance, that is through galvanometer. So for that we will write first the total current value, that is we have calculated it as E into G plus 5, total value of current. And after that we will write the resistance, which is uh, we are interested in finding current through this galvanometer. So resistance left will be R2. So we will write here as R2 and divided by total resistance, that is R2 plus G. So this is the way we will calculate the current through the resistance. Let's say if we have to calculate current through R2, so we would have kept G upon R2 plus G into total current. Alright, so this is the way we will calculate the value of current I2. So from here if you substitute the value of R2 as 5, so this term and this term will get cancelled out, and we are left with 5E and divided by 5E divided by 111 1100 plus of 225 G, and that is equals to theta naught by 5. So here theta we have calculated in the equation 1. So theta naught can be directly replaced as E by 220 plus G. So E by 220 plus G into 5 is already over here. So from here we will solve this equation and we will get the value of G. E gets cancelled out and we are left with 1100 plus of 225 G, and that is equals to this comes out to be 5500 plus of 5G into 5, that is 25 G. Alright, so here the value comes out to be 200 G, and that is equals to 4400. Therefore the value of G can be written as 22 ohm. So the resistance of galvanometer is 22 ohm. So I hope you have understood the concept, and thank you for watching.
Hello students, we have a question. In an experiment set up of meter bridge as shown in the figure, the null point obtained at a distance of 40 cm from point A. Now the condition is, if a 10 ohm resistance connected in series with R1, the null point shifts by 10 cm. The resistance that should be connected in parallel with R1 plus 10 ohm such that null point shifts back to its initial position. So in this question we are given, as we know, at balance condition R1 upon R2 is equal to L1 upon L2. This we have L1 to be equals to 40 centimeter, is what the point, and this is L2 which is equal to 60 centimeter. Now we have 40 upon 60, which can be written as 2 by 3. This is the first condition we have. R1 upon R2 is equal to 2 by 3. This is first equation. Now if we talk about the second condition given, if 10 ohm resistance is connected in series with R1. So we have R1 plus 10 divided by R2. The null point shifts by 10 centimeter. So we will have L1 plus 10, because this point gets shifted 10 centimeter to this point. So L2 will be minused, so it will be 60 minus 10. So we have 50 upon 50, which is equal to 1. Therefore we have R1 plus 10 is equal to R2. We have the next equation, and from these two equations we will find the value of R1, R2 first. So we have, if I multiply 2 both the side in the second equation. So we will get the value to be 2R1 plus 20 is equal to 2R2. Now in place of 2R2, from here we can see that we have 3R1 is equal to 2R2. So we put the value and we get 2R1 plus 20 is equal to 3R1. On solving, we are getting the value of R1 to be equals to 20 ohm. Similarly, we find the value of R2, and the value of R2 is 3 by 2 of R1, which is equal to 3 by 2 into 20. So it is 30 ohm. So we are getting these two values. So these are the two values we have got, and this value we will use for the next condition. This is the one value and this is another value of R1 and R2 we have. Now we use the third condition. This is second condition, this is the first condition. Now as per the third condition, we need to connect a resistance R, connect R parallel to R1 plus 10. So we get the value of this equivalent to be R into R1 plus 10 divided by R plus R1 plus 10. This is what the resistance we have. This is divided by R2, and we have equal after connecting parallel with R1 plus R2 such that null point shifts back to initial position. It means the null point is shifted again to this point which says this is 40 and this is 60. So we have 40 divided by 60. Now on solving this, we can see on putting the value of R1, it will be 20 plus 10, it will be 30. So 30 R divided by R plus R1. R1 is 20, this is 10, it will be 30. So 30 plus R. Divided by R2 is equal to 2 by 3. So the value of R2 we will directly write, that is 30. So we see that these two 30 gets cancelled out. This is divided by 1. So 30 and 30 are cancelled out, and we are remain with the value as R upon 30 plus R is equal to 2 by 3. On cross multiplying, we are getting 3R is equal to 60 plus 2R. 2R is coming this side, and we are getting the value of R to be equal to 60 ohm. So this is the result of this problem, and option C is the correct answer. Thank you.